Yes.
Hello. Hi everyone. I'm glad to be here. So today I'll walk you through my research on Chromium add-ons offensive capabilities. So first of all, let me introduce myself. My name is Riadh. I work as a penetration tester for Synactive for almost 2 years now. So Synactive, we are an offensive security company based in France. And I've been working in IT security for almost 2 years as a penetration tester. I mainly focus on breaking web applications and mobile application as well, and I occasionally develop offensive security tooling. This talk will cover the following. So first of all, a quick overview of the Chromium extensions and why they can be a silent threat. After that, we will see, the goal is to give a clear grasp of how they works and how to build one and how to leverage them for offensive purposes such as red teaming, and also raise awareness for blue teamers. So then we will see how we can load silently a Chromium extensions into a browser. And finally, how this technique led to a tool that will release shortly with a blog post with some detection rules that could help blue teamers. So first of all, let's start with the introductions. Why browser extensions? So OS components such as LSAS are heavily monitored right now. So we have different security mechanisms. So we have user land hooking by EDR. We have credential guard, run as PPL, and sometimes even compromising LSAS isn't enough. So we need to also recover credentials from the DPA API. So the browser right now is the richest target surface for an attacker. And right now the OS just became a bootloader to your browser. And with browser extensions, we have access to those very interesting APIs. So why Chromium-based browsers specifically? Foremost because Chromium-based browsers are roughly 80% of the market. So they're the natural choice for most users in corporate environments. And like Firefox, where extensions can be installed, they disappear once we restart the browser. And compared to Safari, Chrome extension development framework is far less restrictive, so which make it more attractive for attackers naturally. So first thing first, what exactly are Chromium extension? I'm pretty sure most of you have used them. So to block ads or to switch to a dark theme, or enhance your developer tool. So as they call the modular add-ons that extends the browser native capabilities. So from an attacker perspective, this is extremely valuable because the malicious extensions can harvest browser history, capture keystrokes, dump cookies and authentication token, and even modify the page content in real time. So in other words, once an attacker controls an extension, he controls the browser. So regarding the installation methods, the most common one is downloading an extension through the Chrome Web Store or the Edge add-on store. We also have the command line argument as startup. Threat actors sometimes use this technique, but it's heavily monitored. So it's quite noisy for OPSEC, so it's not ideal for stealthy operation. And we have the latest method, which is the developer mode. So we can load an npacked extensions by specifying a folder, or we can self-sign an unpacked extensions to generate a CRX, which is a format of packed Chromium extensions, and then we can just drag and drop and install it into the browser. However, we need to have the developer mode enabled, as you can see on the top right. So as I told you, there's two formats. So we have the packed extensions from the Chrome Web Store. So they're basically signed CRX. CRX is just an archive with some metadata and the Web Store signature. And we have self-signed CRX, so you can self-sign it yourself, but you need the developer mode. So they are not trusted by default by your browser. And we also have the impact extension. So basically, they're just the source files in a local folder. And we can also load them through the developer mode, and they persist across sessions. So let's dive into the Chromium extension structure. So we have, so this is the basic structure of a minimalistic Chromium extensions. So you have the manifest file, which is the most important file. We define the extension information, such as the name, the version of the extensions, and the permission. We also have the service worker and the content script. So content script are basically JavaScript files that are injected into the web page that you visit. So here we just defined matches all URL, which means that the content script will be injected in every page we visit. But they just behave like a normal JavaScript file, so that they don't have extra interesting privilege compared to the service worker. So the service worker is also called the background script. So it have access directly to the browser API. So we can, for instance, here dump all the cookies regardless of their attributes, HTTP only or not. So here we have a screenshot of a service worker script in action. So here we just dumped all the cookies, and we can see that some cookies have the HTTP only attribute. Since we have the privilege of the browser, we can mostly dump anything that is stored on the browser itself. And here we have the content script, which basically operates when we visit a page. So we can dump local storage and session storage. So regarding the capabilities, we can access all cookies with the service worker. We can steal sensitive data on the document object model. Tests, yeah. And we can inject malicious code in pages, take screenshots through the service worker, and intercept modified network requests. So since they are complementary, they can communicate with each other. So here, through the content script, we are sending the local storage data as well as the session storage data to the background. And from the background, we can handle that and exfiltrate it to a server that we control. But it can't access the file system. Actually, it can. So for sure, web pages can't access the local file system because of the same origin policy, but the browser can browse and access files through the file scheme. So unless you have restrictions, the browser can. So the extension also can also browse your file system. So the service workers can leverage tabs and host permissions to open a background window of 1 pixel at a certain locations. So it can parse the content of that page, and then it can exfiltrate the data. And since the browser is able to display text file, most of the text file, so it can recover, for instance, SSH key, some JavaScript or JSON, or any configuration file. So now I'm going to discuss about the extension loading mechanism, how it happens. So first of all, when I loaded an extensions, I opened Process Monitor, and we can see that the browser access the preferences file immediately. So I wanted to confirm that through PowerShell. So I just searched for the string that corresponds to the ID of the extensions, and indeed we can confirm that the preferences file is the source of truth for that extensions. So what it looks like, the preferences file, we have settings. In the settings, we have all the extensions that are registered. We have the extension hash, which is the ID. And under the extension hash, we have our manifest. And we also have the development mode. I will talk more about that in the next slide. And in the end, we have the extension hash, which is MAC, HMAC SHA-256. So there's a signature. So we need to find that MAC in order to sign and load our extension. So we have two goals: obtain a static Chromium extension ID, since we still don't know how they are being generated. So to script all the process, we need to have a deterministic ID, and we need to modify the preferences file accordingly. So we need to sign the MAC or the browser won't recognize, and it will consider the preferences file as corrupted. So by looking at Chromium source code, and we can quickly see on the internet through Google that it is computed by hashing the absolute path of the extension folder. So it's not deterministic. So it's not that interesting for us. But we have a second option, which is the hashing of the public key. So we can generate a key pair of RSA certificates, and it is being hashed. And from that, we can calculate the Chromium extension ID. So we can have a deterministic Chromium extension. So here I just generated a Chromium extension ID. So I have the public key that I will add to the manifest file of my extension. And from that, we will obtain, I will show you in the next slide, that we indeed have this Chromium extension ID. So now we obtain a static Chromium extension ID. We need to sign our preference file. So through a Google research, we just type Chromium preference #mac, and we can quickly see that research has been done in 2020 from Pablo Picasso Sanchez. And basically it speaks more about the secure preferences file, which is used on machines that aren't managed by a domain. And the work explained how the flow affected the integrity checks of that file, but it's, I mean, it was helpful at first, but because it's from 2020, and it mostly affects Chrome version 85. So today we are at the version 140. So I assume that the secure preferences #mac may have changed, and I rechecked it on most recent build. At that time, it was Chrome 130. So the study by Pablo Picasso Sanchez shows that the Chrome #mac seed is embedded in resources.pack at this location, and the fact that it is static across Chrome build and for other browser-based Chromium, such as Brave, Edge, and even Chromium, have basically a null value for this seed. So we can quickly verify that on the Chromium source code. We can see that the browser resource.grd is compiled, and it contains all the data that is being added to the resource.pack. And we can see that there's a preference hash seed.bin. And by cross-referencing this string, we can see that it is indeed used for the profile preference storage manager. So it is still used in the latest version of Chrome. And in his studies, he published this seed that permits the calculations of the preference of the secure preferences file, which is also valid for the preference file. And it is the same SHA-256 key found on Chrome version 130. So from that, I wanted to know exactly which file from the resources.pack. So we have a tool in the Chromium source code, which is packutil. So we can extract the packutil, and I modified a few bytes of that file. And by comparing them through diff, I was able to identify that it was the file 146, and we indeed have the same seed. So even if Chrome update their browser, we can still recover the seed, and I will show you later. We also have the developer mode that has been introduced in the recent version of Chrome, the version 134, and it reused the same key. So the same #mac key to sign the extension hash. It is also used on the developer mode. So we can just switch the developer mode to true, and we can load our extension. So basically, this is just a pseudocode. We have the preference extension settings. We need to inject our extension, and we need to toggle the developer mode. We calculate the #mac for both of those values, and we save the JSON preferences file. So we generate a static extension ID. We place the unpacked extension on disk or on a readable network share. And we did the preference entries under extension settings. We recompute the secure preferences hash MAC or the preferences for all the modified key. And we restart Chrome to reload the preference. And the result I will show you. Where is my mouse? It's strange. Just a second, guys. So I'll try to mirror my screen. It will be easier to control it. Yeah, keep changes. Should see my screen. Yeah, perfect. So quick demonstrations of the tool that I've developed. So here we can see that the developer mode is disabled, and we can see that it is the latest version of Chrome. So with my script, we're just checking the extension, we sign it, and we upload it through SMB. And then we can see that we have our extension loaded. And from this V2, we can control the browser. So we can get the cookies, for example. We can also have screenshots of the tabs. And we can also browse the file system directly from the Chromium extension. And we can also intercept post requests that are being sent. So for instance, I just try to log in with test and it works. Here we can see that we indeed captured the login and the passwords. Okay, so I join up. Ouch. Just need to full screen mode, sorry for that. Okay, so now we are going to see the administrative restrictions that you can put in place. So we have group policy object on Windows, so we need to install the Chrome administrative templates, and we can basically allow certain extensions with allow list and block lists. However, we can verify that through the Chrome policy. So indeed, we have blocked all the extension with the extension install block list. But the fact is, even if you deploy a GPO on the local machine, they are being added to the HKCU with the current user. So if a malware infects a device, he can basically remove these restrictions. He can delete the registry key, extension allow list, and block list. So there is no protection at this point. There's another technique to bypass this is the extension ID spoofing. For instance, since the Chromium extension ID is calculated from the manifest key, so we can basically download Adobe Chrome PDF. We open the service worker to have a dev tool in that context, and we can recover the key, the public key. And from that key, we can impersonate and have the same ID as Adobe Acrobat PDF. So if it's not installed, we can inject it. but if it is installed, it will stomp the old extension. So here we have Adobe PDF, and then we load our extensions, and the browser will choose our extension, our impact extension. So regarding the prevention and the detections, I recommend that you define manually through HKLM, so hotkey local machines, since they are privileged by your browser. So the order is HKLM policy first, then you have the cloud rules that you can develop through Google Administrator, through the Google Admin Cloud panel, and the latest comes the HKCU. So ADMX template typically populate user scope, HKCU. So the recommendation, so as I said, the recommendation is to add HKLM, and by default you should only allow certain extensions. However, and also I recommend that you monitor the preferences file, and also monitor any registry hive changes on those locations. And if you are administrator, unfortunately, it's too late, since all security measures can be disabled. HKLM or HKCU, they can simply be removed. And if an admin is compromised, it's almost too late at this point to prevent any software mitigation. So we also have some tools that have been released few weeks ago. So we have the Chrome Alone C2 and the loader from Michael Weber. We have the Riadh X C2 from Darkrain, and we also have a loader which is the Sharp Silent Chrome loader that has been released also. So this is the reference, and thank you.